Alright, ladies and gentlemen, today we're going to learn how to find the least common multiple using a variety of different methods. And this is our objective today, that everyone will be able to find the least common multiple for two or more numbers using a variety of methods. Why is this important? Many people ask this, and I know we confuse greatest common factor, GCF, and least common multiple, and least common denominator, LCD. And sometimes these things can be confusing. But if we remember, least common multiple and least common denominator are very common terms. The least common multiple will actually help us to find the least common denominator when we have to have a common denominator when adding and subtracting fractions or comparing and ordering fractions. So let's check it out. First method we have here is the listing method, and you can see the steps. This is probably what you learned when you were in elementary school. When you list the multiples, so 9 times 1 equals 9, 9 times 2 equals 18, and we can go through and list the multiples for both of the numbers. And if we're trying to find a common multiple between the numbers 9 and 12, we can list the multiples for 12 as well. And we end up with all of these different multiples. When we circle the common ones, we can see 72 is common and 36 is common. And the lowest or the least of those common multiples would be 36. So this is the older method. It takes a little bit more time, but really helps you to see what's going on. This is what we're going to be completing today, involving the division ladder method and also learning the Venn diagram method. So let's move on. First, we want to look at the Venn diagram method, and the first step to solving or finding the least common multiple using this method is to find the prime factorization for both of the numbers. So in our example here, we have the number 10 and we also have the number 16. We break it down and find the prime factorization, and here we have the division ladder or the factor tree, and you can use either method. But the most important thing is that we are finding that prime factorization. Here we have 2 to the 4th power, or 2 times 2 times 2 times 2, and 2 times 5. The next step, and this is step 2, again, if you're taking the notes, we want to kind of remember step 1, and we've got some of those problems right over here where we can see the prime factorization of 16 and 10. And then what we're going to do is we're going to put those prime factorizations inside of the circles. So this black circle is the circle for 10, and the green circle is the circle for 16. We put the prime factorization in. Now, since they have a 2 in common in both of them, we're going to put that 2 actually in the middle. That's the number that they share. And we'll just cross out the 2 from each of these boxes for right now. That's the second step. The final step is we're actually going to erase that 2 that was outside that we circled and crossed out. And now we need to multiply all of the numbers together to find the least common multiple. So we're multiplying what's left over in this circle, the number they have in common, and what's left over in this circle. And when you do this, you end up with the least common multiple of 16 and 10, which is 80. That was the Venn diagram method. It really helps you to kind of see what's taking place when we're finding least common multiple. The next method that we have is the division ladder, and this is probably the best method when you have a more complex problem. If we have 3 numbers, or if they're really large numbers or something like that, this method is my preferred method. We want to start by writing the 2 or more numbers in the division ladder. So here we have our division ladder with 12, 14, and 16. That's step 1. In the second step, we're actually going to break this down and solve with the division ladder. So actually, if I pull all of these numbers down, and I'm going to kind of get them out of the way down here, the first thing I ask myself using my divisibility rules, are all of these numbers divisible by 2? And they are, because they end in 0, 2, 4, 6, or 8. Then I go ahead, and 12 divided by 2 is 6, 14 divided by 2 is 7, and 16 divided by 2 is 8. The next step is to ask if there's any common factors between these numbers that we have remaining here. Since 6 and 8 have a common factor, but 7 does not, then we're going to circle the 7 and write our common factor for 6 and 8 here. 6 divided by 2 is 3, and 8 divided by 2 is 4. Now, since 3 and 4 don't have any more common factors, we circle them, and we've completed step number 2, circling the ones that are not common, and then the ones that are common we put off to the side. Finally, all we have to do is multiply all of those common factors to find the least common multiple. Notice the circled numbers and the ones on the side. Could you imagine using the listing method to get a least common multiple of 336? And that is why using the division ladder method is probably the best method for a more complex problem involving multiple numbers. Well, I hope this helped you out. See ya!